to the practice of football. If you don't know this about AstroTurf, so you may think that football is obvious, and you may think that the inflation of footballs is obvious, and you may think that the inflation of, or the deflation, I should say, excuse me, of footballs is an obvious thing. But as you can see from this graph, it's not. And the reason is that what you expect is the solid line. You expect that when people are tweeting, what that does is it actually sucks the air out of pretty much everywhere, including the inside of footballs. And so you start out with a whole lot of air to begin with, and then as the tweets increase, it goes away. But in fact, what happens is that you start out with no air. And then there's tweeting, and you get air. And then the tweets continue, and you get no air again. It's the Goldilocks principle of tweets and footballs. You've all heard of that, right? My famous paper, right? Which Adam did not cite. So that's why I sent his paper back. So really, it's this connection between tweets and footballs that we're interested in, and we're especially interested in the fact that it's not monotonic. What the heck is up with that? I'd ask you. Why do tweets sometimes put more air in, and sometimes take the air out? Right? I am bewildered by the whole entire thing. So before I show you the next slide, I have to warn you that it's logarithmic. That means that, well, I'm supposed to. Okay. One can measure the drag force on a football. And usually the way that we do this is we actually film the footballs with our iPads in lab. Especially first-year lab. This is what we do, right? Is film the footballs. And often we'll film them as we drop them off the roof of a building. This was actually far more effective when we used to do it in the old building. Because it was much higher than this one. Right? But so, well, we're stuck with this. So I have old data on here, and I have new data on here, and you can see that they don't agree at all. This is a giant mystery. Okay. So, we've already talked about tweets, and we've talked about how tweets have something to do with the amount of air in the football, and now we have to talk about procession. So I want everybody to stand up. Now you're all already familiar with rotation around an axis, so I want everyone to rotate around your own axis. Good. Now picture a top. What a top does is it goes around its own axis, and then that axis gradually falls over and starts making a bigger circle, yeah? Do that. Excellent. All right, thank you, everyone. Good. So this is one thing that we're interested in with footballs, because the amount of air that's in the football can tell us something about how it's going to process as it travels from the quarterback to the receiver. So as it travels, the football will process somewhat if there have been too many tweets. If there have not yet been enough tweets, the football may be underinflated, but it does not process. So this is how we can tell the difference between whether we're on the left side of the hill, the tweet hill, or we're on the right side of the tweet hill. It's because whether or not the football is actually processing. Is that clear? Yeah? Okay. Good. Okay. So, in conclusion, what I want to say is that, go Patriots. I'll take questions.
Is there, by chance, a correlation between the precession of the football, which relates on tweets, and the formation of a black hole?
Right, this is a really good question. And the really important thing to realize here is that this graph goes on that way much further than we've shown here. We have predicted that there's a second zone of stability, so to speak, way over here on this graph, where after you pass a whole lot of numbers of tweets and then they keep going up and they keep going up, you're going to hit another point over here where, in fact, the dotted line rises up to infinity. We are very concerned that we are approaching that limit now. That's, I mean, you know, black holes, people.
Yeah, you've been talking about tweets and air and stuff, but can you comment on how the air temperature might have something like hot air
Versus cold air. Are you talking about ambient or within the football itself?
within the tweets?
Oh, within the tweets. So, you know, that's a really interesting point. I have not investigated that myself, but I did recently come across an article in Nature where they were talking about that. But it's honestly, it's sitting on a stack on my desk. Yeah. Tim?
Towards the end of that graph where it goes up to infinity, do you still get Pandora there?
Yes, because it's wireless.
If we can figure out the location of where the air will be inflated and the football via tweets, can we use the same logic to predict where the black holes are?
We can, and in fact, that's why we're so concerned about what's going on now, right? One of the things that's an interesting application of this research, because you might think, well, who cares, really? I mean, if we wind up making a black hole here on the planet, who cares? But one thing that does matter is that if you think about the size of a lung and the size of a football, they're about the same. So if the amount of air inside of footballs is changing with the number of tweets, then it makes sense that the amount of air inside of lungs is also changing with the amount of tweets. And so we're very concerned that this is actually going to turn out to be related also to, for example, environmental conditions along the last section.
So if we all continue to tweet more and more, will we lose the ability to create vacuums here on Earth?
Because what's going to happen as we tweet more and more is that the mass that's here in the environment is going to wind up compressed into a singularity. And as you know, if you just think about it for a few minutes, you'll be like, well, what does that leave behind it? And you'll realize it leaves behind a giant vacuum with nothing in it, right? So it's a little bit the opposite of what you would expect intuitively. But as I continuously tell my classes, intuition is garbage.
Could you go to your conclusion slide? Okay, I was trying to figure out what's happening on Sunday.
The superb owl.
The super owl, yes.
Now, what if our liver continues to,
Yes.
what effect is that going to have on the vacuum?
Right.
Maybe you just answered it, but I can relate that.
To what's actually happening.
What's actually
Yeah.
happening.
Yeah. So this is interesting to think about because one of the questions that we have with the fact that these two pieces of data don't agree, right? So we have old data on the top and we have new data on the bottom. And what you're seeing there, we think, is that the nucleation site of the black hole changes. It used to be that the nucleation site of the black hole was like somewhere off the Pacific coast. It appears to have moved to Washington.
Hashtag these folks, slides and presentations. I will award the award at the next seminar. So thank you all for coming. That is the end.